What was the last lecture?
It was supposed to submit the assignment.
Hmm? Before the presentation, we covered about the distributed architecture, and before that we covered MVC. MVC. What is MVC? What is model? What is view? What is controller? Abdul Rahman, Khaled, Darvesh, yes, Haitham.
HLF separate between the application logic and the business logic. The aim for the modeling and view and control. Like in Java model, the view is like the GUI, the control is like the code that we write. The modeling control.
Controller is linked with the event, and you have a model that contains your logic, the business logic. The application logic is on the view. So whenever user initiates, activates some event, the controller will pass this information to the model, like shopping cart, to update the shopping cart. Any information that is passed to the view or to the model, that must has to pass through the controller, like a mediator, manager, managing all information. Then we discuss about Korba. What is Korba? Abdul Rahman? Yeah?
Common object request broken architecture.
Mm. How to define? Yes, Mr. Khalid? Korba divides the architecture of different programming languages developed by different vendors so that they can intercommunicate with each other to achieve interoperability. To achieve interoperability, intercommunication, so they can communicate with each other, like Java to .NET, Java to C, C to C++. C is structured, Java is object-oriented. Fortran, Cabol is structured. You can communicate with the object-oriented, and object-oriented to object-oriented. Java to PHP, PHP to Java, PHP to .NET, .NET to PHP. How how Korba works? Korba was introduced by OMG, Object Management Group, in 1990s, 91. In Korba, you have to use repository. Repository is a database in which all the components are registered, like the registry of Windows operating system. So you have network, LAN, MAN, MAN. You have networks, LAN, MAN, MAN. So over the WAN, the servers are different. Like one application needs some data or function from the other application that is running on another server. So this application will pass a message to another application to provide me this data, to import data. And the other application will provide data export. So import interface and the export interface will be created. So requesting application becomes client and the service providing application becomes the server application, client application and the server application. And Corba is working in between them. So we use ideal. Anybody knows about ideal? Interface definition language or interface description language? Ideal. So you have to use ideal, which is an interface before the client application and before the server application. Like I show you on the board. Client, server, application. Here we have repository. The registry. So ideal at the client side is called stub. And ideal at the server side becomes skeleton. So you have to write an interface to communicate between client object and the server object, client application and the server application. So interface definition language is providing the interface for communication. And this one is running on operating system server, where components are registered, functions are registered that you want to call and you want to use to communicate. And ORB is a service that breaks the architecture of client application and the server application. Object request broker. Object request broker. That will break the architecture of different programming languages, different formats, to make them unified so they can communicate with each other. And all the communication is through the stub and the skeleton. Stub. At the client side we call this interface stub, and the server side we call it skeleton. Both are stubs actually, but to differentiate between them, the client and the server side, we call it skeleton. Otherwise it is also stub. Module. You have to write code to communicate between them.
The IDL defines language is used.
You will write a code. So what component you want to call? It's an interface to import and export. So this is providing the export, this is providing the import. When this data will be provided, it will receive and pass it to client application. So client application can use that function or data. So there is a call, response.
The IDL and ORB is different.
ORB is a protocol, it's a service that is breaking the architecture of .NET and the Java. So they can have communication because their standards are different, their specifications are different. So, but the problem, there are two problems. First of all, you have to pay license to OMG to use Corba. Then this stub and skeleton will work. ORB will work to break the architecture.
So you have to pay.
Yes, you have to pay. Second thing, you have to learn a new language which is interface definition language. It's a programming language to write stub and skeleton, to provide interface, import and export, how to call and how to provide a service.
In each server, client we need this to
Yeah, and you have repository where your components or the functions are registered that you want to call or you want to use. Like in the operating system registry, whenever you install new software, it is registered in the repository or the registry of the operating system. In Windows, there is a registry. You know this or not? Now, Sun Microsystem was not happy with this Corba architecture because Java is free. But to call applications, you have to use Corba. Then you have to pay. So companies start complaining to Sun Microsystem. Provide us some solution so we don't need to pay. Then Sun Microsystem introduced JNI, Genie architecture. So using Genie, you can call, but before that, there is a calling RPC here to call the remote procedures through the IDL, remote procedure call. There is a call, remote procedure call, RPC. In Java, to call the methods, we have RMI. Have you used RMI in Java? No. RMI is to call objects from another application over the network. From one Java application to another Java application over WAN, over the internet environment, from one server to another server. Like you import java.io.stare, you have to include the package RMI package. There is RMI package. So now then, using RMI package, you can call remote objects using Java to Java. But from Java to .NET or Java to PHP, you have to use Corba. Then Sun Microsystem introduced JNI, Java Native Interfaces, Genie architecture. So using RMI plus Genie, you can call any object from Java to non-Java. Java native interfaces. Yes, Java native interface. Similarly, in Java we have JSF, Java Server Faces, JSF. Java Server Faces, JSF is there. But to call from Java to non-Java, RMI plus Genie, it will work. like the Korba. No need to pay. You can call from any application, from Java to C, Java to .NET, Java to PHP.
They must be very
Hmm?
angry.
Yes.
They must be very angry.
Yeah, but this is market. Because they introduced their technology. And Sun Microsystem always said we are free. No license. So they cannot complain. Like Linux, Unix is there. Windows can't do anything. Huh? They cannot say why you introduce free operating system Linux, Unix. If your technology is good, people will pay. Make it good.
Even now, the company, they have the operating system like Apple. Apple, they make Macintosh free. No, you can't download it.
Now,
Yeah. Now they make.
now it's too late. Market is already captured. It's too late. Now you can download. Even you can use Windows on Macintosh, Apple machine. Now you can use Windows on Apple machine. But it's too late. Already market is captured. Anyway, then Microsoft has DCOM architecture. It is distributed architecture like the Korba and like the RMI, EJB. In Java, the components are called beans. So enterprise Java beans are there, entity beans are there. Have you used beans? NetBean is the framework. Have you used beans? Enterprise Java beans, EJB, AEJB. Beans are components. Beans are components that are developed, customized components. To call applications from one application to another application, to provide any functionality like reporting, like log, component. So these are the components. Like in .NET you have components, command button, text box, label box. So in the Sun microsystem you can use components which are beans. So you have enterprise beans, you have entity beans. For session handling you use beans. Session. So enterprise beans are there, entity beans are there. Anyway, Microsoft when you will leave, then I will continue. You have to go and then you will come back after my lecture. You said I left some things.
Yeah, I left something to download.
Then you have to do it after my lecture. If it needs 3 minutes.
Sorry, doctor.
I will finish at
No problem, you can take your time.
3:50.
Thank you, doctor.
Welcome. Microsoft has architecture, its name is ActiveX architecture. ActiveX technology. ActiveX technology. Have you heard about ActiveX technology?
The one that shows in the Internet Explorer.
Yeah, in the Internet Explorer they are using ActiveX. ActiveX technology is composed of 3 sub-technologies. We have ActiveX components, we have ActiveX controls, and we have ActiveX documents. ActiveX components, Active X, yes, Active X. Yes, active.
Document.
ActiveX components, ActiveX controls, and ActiveX documents. There are components. There are 3 types of ActiveX technology. distributed architecture. In the ActiveX components, Microsoft has three technologies: COM, DCOM, and OLE. COM, DCOM, and OLE. We are talking about DCOM here. The COM, anybody knows about COM? COM is component object model. Component object model. DCOM is the distributed component object model. Distributed. Distributed COM. COM was used for local applications, desktop applications. Then distributed DCOM was introduced to run local application remotely over the network, over LAN, MAN. And then OLE, object linking and embedding. Embedding. To embed one application inside the other, like Excel object inside the Word has Excel. Browser has Word, Excel, PDF. So one object can contain other objects. One becomes the container, other is the contained, like a container. So you have OLE technology, object linking and embedding. So you can link Word inside the Visual Basic. Visual Basic or VB6 or VB.NET can integrate Word within the form window. Excel you can integrate with the .NET or with the Visual Basic. Have you tried to use?
What object inside of it?
Yeah.
In Word, we can
Now, have you used Visual Basic to integrate Word or Excel inside the form window or the VB.NET or C#? Have you tried? But you should experiment by yourself. Our field is practical, hands on. It's not just like you can see. You have to experience these things, because you don't know when you will go in the practical life, where you will get the job, what are your job tasks. Then you can't say, I don't know how to do it. Can say? You cannot say like this. Just do it. Say yes, you will do. Then that time you will be in trouble. Anyway, so DCOM is used to run the distributed applications. Now, like in browser, is using ActiveX components, DCOM technology. Another technology we have COM+, which is extension of COM and DCOM. COM+. So the new technology by Microsoft before the Visual Studio .NET. But .NET is still using the ActiveX technology. It's compatible. There is compatibility. So we have DCOM, we have EJB, we have Corba. These are the three popular architectures. RMI, Gini architecture. Enterprise Java Beans. Using the RMI and the Gini. Gini technology is very popular for embedded software. Like you can on microwave oven from office by just making a call. So when you will reach back home, your food is hot, cooked. Or to open the door, door lock, like the voice recognition system. It will only open by your voice. So no need of the key or any other thing. Or the tricircle locks, no need. China lock or anything, Japanese lock. It will open only by your voice. So it's a high security.
What if I get the
Your throat is not working. Then pray. Anyway, you always have a backup system. It doesn't mean there is no alternate. There must be some alternative. But these are the distributed architectures we have. So you can see here RPC, the remote procedure call. Remote procedure call RPC, which is calling, I remove the picture, which is calling the remote objects. And messaging is there, conversation is there. So we have marshalling and unmarshalling concept is there.
Yes.
Have you heard about marshalling and unmarshalling? Marshalling. When a call, you send a message as a packet, as a envelope. So it's encrypted. It has the method you are calling, its attributes to call the correct function or the correct method. So at the server side, it is unmarshaled, open by the server application, by the RPC, by the IDL. What is the message? What is the service we need to provide? Then the data is again sent by using marshalling over the network. So over the network, nobody can see what is the message, what is inside the envelope, sealed, encrypted. You know encryption and the decryption? Encryption, decryption. Encryption, decryption. Encryption, we convert the data of normal text into unreadable text. We call it ciphertext. Ciphertext. Like sometime your same thing over the network, if somebody will try to open, he will see it's a garbage. It's a corrupted. But actually it's encrypted. You cannot read. At the receiving end, it is converted back into normal text. Decryption. So we have keys to encrypt and decrypt. But anyway, when client application send message to the server application, so it will send by using marshalling.
So it should be encrypted.
Yes. So over the network, because it's over the internet. When it will pass over the internet, nobody can read. At the server end, receiving end, it's unmarshaled. And then server application knows what is the service of the data it has to provide. Then it will send the data again by using marshalling. At the client end, it will be unmarshaled and the data is received and the processing is done. You got something? Sure? So we have commercial frameworks. Microsoft Transaction Server is there, Corba, Enterprise Java Beans, SAP, Delphi, Ford, Visual Basic, Domino. So this is the DCOM architecture, the remote architecture, the remote applications. So we have client side and we have the server side. This is a Microsoft Transaction Server. So we have client, we have server. So we have stub interface. to communicate with the server. So class factory wrapper, so wrapper classes are there. So class factory wrapper, context object, class factory and Microsoft transaction server objects. For e-commerce, we use Microsoft transaction server. BizTalk server is there. BizTalk. Yes. BizTalk. You can see BizTalk server by Microsoft.
This not give you the server, okay?
Business.
For payment processing.
Yes. There is something wrong. Slow. Network is very slow. But you got the idea. So we have BizTalk server, we have MTS, Microsoft Transaction Server is there. My objective is not to teach you BizTalk server or MTS because I am teaching another subject. I am not teaching you e-commerce, I am just explaining you the concept. And then we have the Corba, the application objects, the Corba facility, user interface, information management, system management, task management, Corba domains, the financial services, healthcare. So in all these sectors we are working. Object request broker service to divide the architecture, the protocols and the specifications so they can communicate. The Corba services are there. Concurrency, event, externalization, licensing, lifestyle, naming, security, time, trade, startup, persistence, blah blah blah.
This is all the element of the Corba?
Yes?
Okay.
Huh?
All the element of Corba is just no client and no server.
No, no. I did not provide you the diagram, but it is there. That I show you on the board. It is there. The EJB architecture, enterprise Java beans. So remote protocols are there using the RMI and the Gini. I think it is enough for today.